Okay, so in this video, we're going to go over the basic rules of probability, and then we're going to go over a couple examples showing how we can use them to solve some problems. All right, so the first one says the probability of any event is always going to be between 0 and 1. 0 meaning that it never occurs, and 1 meaning that it always occurs. So for some event A, we say the probability of A is greater than or equal to 0 or less than or equal to 1. And remember, we like to use capital letters to denote events and probability. And this capital P means probability, so probability of A. Second rule says that all of the possible outcomes must have their probabilities that add up to 1. So in all the things that could happen in in the universe, if you took all their probabilities, it would have to add up to 1. If it doesn't, then there's something wrong with your model. And again, we like to use capital S to denote the sample space. So we say that the probability of S is equal to 1. Remember, the sample space is a set of all possibilities. All right, third rule says that if all the outcomes in the sample space are equally likely, the probability that an event A occurs can be found by using the formula. So the probability of A is equal to the number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. Now, this kind of seems like a weird rule, maybe a little confusing, but let me just give you an example. So like, let's say you're rolling a die. So a fair die with, numbers 1 through 6. Each of those numbers 1 through 6 have an equal chance of coming up. They each have a 1 in 6 chance of coming up. So let's say you're trying to figure out the probability that you would get an even number. So what's the probability you would get a 2, 4, 6? So you basically, take 1 6 plus 1 6 plus 1 6, and that will give you the probability of getting an even number. Now, again, it'll be a lot more intuitive when we go through some examples, but this is just a formal way to write it. All right, the fourth rule says that the probability that an event does not occur is 1 minus the probability that the event will occur. So we call this a complement. A complement. So if we have an event A, the complement of A, we denote it as like the event A, but with the C in the spot where you would normally write an exponent. But it's not A to the C power. This is just the notation we use to write a complement in probability. And this means the outcomes that correspond to everything that's not in event A. So again, just think of it in the most simple way. Either event A occurs or event A doesn't occur. So every situation in life can be broken down into those two possible, into those two possible events. Either something occurs or doesn't occur. For example, let's say like either you're gonna, you're either gonna go to school today or you're not gonna go to school today. It doesn't mean that it's not gonna give you specific details on what you did instead. It just says either go to school or not go to school. Either you're 7 feet tall or you're not 7 feet tall. It's not saying how tall you are, but you can always break things into their complement, into the event of it not occurring. And this is very useful. Well, you're going to see when we go through some problems. And again, it makes total sense because that means the probability of the complement of A plus the probability of A will have to add up to 1. So when you can just take away the probability of A from one side, and the probability of A complement will be 1 minus the probability of A. All right, and the fifth rule says that if two events have no outcomes in common, then the probability that one or the other occurs is the sum of their individual probabilities. So if events A and B have no outcomes in common, then we say the probability of A and B is equal to 0 because they both can occur together, and the probability of A or B is equal to the probability of A plus the probability of B. Think of this as, again, this is just another way to say disjoint to events. If you have disjoint events. So it's like if you flip a coin, you either can get heads or you can get tails. You can't get both heads and tails on one flip of a coin. So these are going to, be what are disjoint events or events that have no outcomes in common. Okay, so let's go through some examples, because again, that's always the best way to really understand this stuff. Okay, so here we got a table that shows these AP statistics scores from the 2013. And then you can get a 1, 2, 3, 4, or 5, and this was the corresponding probability or the proportion of students that got those scores. So part A, so show that this is a legitimate probability model. Okay, so in other words, show that this makes sense in the world of probability. So one thing we can check is that each event has a probability between 0 and 1, which they do. None of them are below 0, none of them are above 1. So that checks out. So we could say all events have probabilities between 0 and 1. And then other things we have to check that they as a total sum of the probabilities add up to 1. So for that, let's go ahead, let's crank out our calculator. So 0.233 plus 0.183 plus 0.235 plus 0.224 plus 0.125 equals 1. So it checks out the sum of all the probabilities out to 1. So we're good there. All right, now part B. Find the probability that a chosen student, chosen student. So again, we're going to say we're choosing a student at random. That we can choose a student at random and they had a score of 3 or better. So let's just think about this. If they have a score of 3 or better, that means they could either have a score of a 3 or 4 or 5. So since you can't get both a 3 and a 4 or 4 and a 5, just to find this probability, you just simply have to find the probability of a 3 plus the probability of 4 plus the probability of 5. And we can write this like this. Please add those numbers up. So 0.235 plus 0.224 plus 0.125. And we would get 0.584. So there's a 58.4% chance that we would randomly select a student that got a 3 or 4 or a 5. So got a 3 or better. All right, let's look at the next example. Okay, let's say we have an American adult. We're going to choose an American adult at random, and we have 2 events. Event A is that the person has a cholesterol level of 240 milligrams per deciliter of blood or above. So they have high cholesterol. And B is that the person has a cholesterol of 239 milligrams per deciliter of blood. So they have borderline high cholesterol. So according to the American Heart Association, the probability of A, or the probability of having high cholesterol, is 0.16. And the probability of B, or the probability of borderline high cholesterol, is 0.29. Okay, so part A, explain why events A and B are mutually exclusive. So let's recall what mutually exclusive means. Mutually exclusive, same meaning as disjoint, and that's essentially saying that the events both can occur together. They both can occur. You can't get both if you select one person at random. They both can't have an A and a B. In other words, they're disjoint because a person can't both have a cholesterol level of 240 or above and 200 to 239, and a cholesterol level from 200 to 239 at the same time. Doesn't make sense. So then those would be mutually exclusive. So we'll just write that. A person cannot have a cholesterol level of 240 or above, and between 200 and 239 at the same time. Between 200 and 239. All right, part B. The same plain language what event A or B is, and what's the probability of A or B? Okay, well, A or B is just saying that either you have a high cholesterol level or a borderline high cholesterol level. So that just means that you either have you just have a cholesterol level of 200 or above. So you could have 210, 230, 250. It would count as it being events A or B. So we'll say having a cholesterol level of 200 or above. And then what's the probability of A or B? Well, since you can't get them both, you just add them up. You just add what the probability of A is and add it to the probability of B. So the probability of A or B is just going to be 0.16 plus 0.29. That'll give us 0.45. All right, in part C. If C is the event that a person chosen has normal cholesterol below 200 milligrams per deciliter of blood, what's the probability of C? Okay, so this is an example of how we can apply the complement rule. So either a person has normal cholesterol or they don't have normal cholesterol. So either they have cholesterol below 200, so either cholesterol level below 200, or they don't, which means they could have a cholesterol level above 200. We don't care exactly if it's 201, 250, 500, or whatever. We just care that's not below 200. So since we know that having a cholesterol level of above 200 is 0.45, that means the probability of having the cholesterol level below 200, or the probability of C, will just be 1 minus the probability of A or B, or the probability, or 0.45. And that would simply be 0.55.